Good morning, everybody. Myself, Dr. Alok Kumar Das, going to present our development of hybrid micromachine technology using chemical-assisted spark machining process. So this technology had been developed uh, by the combined effort of my research scholars, myself, and the scientists from DRDL Hyderabad. So this technology has been developed for their specific purpose of micromachining in superalloys and also in composites, in ceramics. This slide shows the difference between the micro EDM, micro ECM, and micro ECDM. ECDM is electrochemical discharge machining. Here we are combining both the processes, micro EDM process and micro ECM process, to take advantage of both the process. So by combining, we can machine uh, almost all material, and we can get better geometrical accuracy as compared to micro ECM process, and better surface integrity as compared to micro EDM process. And as I told you, it can machine almost all type of material regardless of their strength, hardness, toughness, with improved surface integrity and MRR. So this slide shows some micro level details of the process. It combines micro ECM principle and micro EDM principle. In the micro ECM, basically tool electrochemical reaction takes place between the tool and the job when required potential is applied across them. So in both the cases, in micro EDM and micro ECM, we use pulse power supply. So this shows the combined effect of micro ECM and micro EDM process. Uh, we are putting two electrodes in the electrolytic cell, and the conductive or non-conductive material as a workpiece kept below the tool. So for example, in this diagram, it is non-conductive workpiece. So here, to initiate the electrochemical reaction, we have to use an auxiliary electrode. So the electrochemical reaction takes place between the tool as well as between the tool and the auxiliary electrode. So electrochemical reaction followed by evolution of hydrogen gas bubble will form, and it will be accumulated over the tool surface. And at the end, a gas film is formed. This is called passivation layer. And due to formation of passivation layer, there is no further electrochemical reaction. Now, if we increase the voltage across the electrodes, at certain point of voltage, the spark is established between the tool and the electrolyte. So if we keep the material, work material below the spark, then it will be melted and evaporated. So this image, this FECM image shows the machine micro hole in super alloys. So you can see it is having very clean surface, and we found that the surface integrity is much more better than the micro EDM process. Based on this principle, we have developed a setup, commercial setup, it consisting of a CNC controller, a pulse power supply, and also a electrolyte supply unit. We have modified this spindle, and also we have developed, included this new type of pulse power supply. And this is the spindle assembly. The spindle assembly is totally uh, isolated from the machine body. And in this setup, we have used professional milling controller, make Siemens, and we have filed one Indian patent also. It has been granted. This machine presently being used at DRDL Hyderabad, and they are using it for micro machining of different composite materials, and ceramics, and also they are using it for deburring operations, micro deburring operation. This is the working of the spindle for machining of composite materials. So it is a very good potential market potential, as this machine can be widely used for machining of superalloys, machining of composite, machining of any conductive non-conductive materials. Also, this can be utilized for micro machining operation of small components. As I previously told, that it can be effectively utilized to improve the surface in situ improvement of surface integrity. So, which is basic requirement of this micro component machining, and it has also very good social and commercial impact. It would enhance the manufacturing capabilities of different industries. It has many advantages as compared to uh, micro ECM process as well as micro EDM process. Thank you so much.